According to the 2002 National Electrical Code, a 15-amp circuit can support 10 receptacles at 180 volt amps per yoke. In this analysis, there are also 2 switches in each of 2 rooms that control separate ceiling light and fan functions. These switches are on the same 15-amp circuit as the 10 receptacles. The goal is to determine if the circuit is overloaded according to code. Firstly, calculate the load for the receptacles. 10 receptacles multiplied by 180 volt amps per receptacle equals 1800 volt amps. Secondly, calculate the load for the ceiling lights and fans. There are 2 switches in each of 2 rooms, resulting in 4 potential utilization devices, either 2 ceiling lights and 2 fans, or potentially just the ceiling lights if the fans were installed later. Consider 2 scenarios. Scenario 1 assumes ceiling lights only. Scenario 2 assumes ceiling lights and fans. In Scenario 1, assuming ceiling lights only, it's assumed that the fans were not installed when the house was built. Each ceiling light box has a potential load of 60 watts, which is the standard wattage of a ceiling light fixture. Therefore, 4 ceiling light boxes multiplied by 60 watts per box equals 240 watts. In Scenario 2, assuming ceiling lights and fans, it's assumed that the fans were installed later. Each ceiling light box has a potential load of 60 watts plus 100 watts, where 100 watts is the typical wattage of a ceiling fan with a light. Thus, each box has a potential draw of 160 watts. Therefore, 4 ceiling light boxes multiplied by 160 watts per box equals 640 watts. Thirdly, calculate the total load on the circuit for each scenario. In Scenario 1, with only ceiling lights, the total load is 1800 volt amps from the receptacles plus 240 watts from the ceiling lights, which equals 2040 volt amps. In Scenario 2, with both ceiling lights and fans, the total load is 1800 volt amps from the receptacles plus 640 watts from the ceiling lights and fans, which equals 2440 volt amps. A 15-amp circuit at 120 volts provides a total capacity of 15 amps multiplied by 120 volts, which equals 1800 volt amps. However, for continuous loads, which are loads expected to operate for 3 hours or more, the National Electrical Code requires that the circuit be derated to 80% of its capacity. Therefore, the maximum continuous load on a 15-amp circuit is 1800 volt amps multiplied by 0.80, which equals 1440 volt amps. It is important to check local codes as they can be more restrictive than the national guidelines. In Scenario 1, with only ceiling lights, the circuit is overloaded by 240 volt amps if considering only the 1800 volt amp limit, or 600 volt amps if considering the 1440 volt amp limit. In Scenario 2, with both ceiling lights and fans, the circuit is overloaded by 640 volt amps if considering only the 1800 volt amp limit, or 1000 volt amps if considering the 1440 volt amp limit. Considering a standard circuit breaker trip rating of 80%, a 15-amp circuit should not exceed 12 amps continuously. 12 amps at 120 volts is 1440 volt amps. When calculating the total load, convert all wattage to volt amps. The calculation for volt amps is watts divided by the power factor. The power factor is a measure of how effectively electrical power is being used. For purely resistive loads, such as incandescent lights, the power factor is close to 1. For inductive loads, such as motors, the power factor is less than 1. In most residential calculations, a power factor of 1 is assumed, which means that watts and volt amps are considered equal. A more precise calculation would involve measuring the actual current draw of each device and using that information to calculate the total load. Using the initial calculation based on standard wattage values, the circuit does not meet the requirements of the 2002 National Electrical Code in either scenario. It is recommended that a qualified electrician inspect the circuit and make any necessary corrections. Another approach is to add additional circuits to distribute the load. This would involve running new wires from the electrical panel to the areas where the load is high. If the existing wiring is undersized, it may need to be replaced with larger gauge wire. This is a more complex task that should only be performed by a qualified electrician. Alternatively, energy-efficient lighting and appliances can reduce the overall load on the circuit. Switching to LED lighting can significantly reduce the wattage consumed by the lights. Using energy-efficient ceiling fans can also reduce the load on the circuit. The National Electrical Code Article 210.11 specifies branch circuits for dwelling units, outlining requirements for the number and type of circuits needed. Article 210.12 requires arc fault circuit interrupter protection for many circuits in dwelling units to protect against electrical fires. Article 210.19 specifies the conductor ampacity and size requirements for branch circuits. Article 210.20 covers overcurrent protection for branch circuits, ensuring that the circuit is protected by a fuse or circuit breaker of the correct size. The National Electrical Code Table 220.3b lists general lighting loads by occupancy, which provides a starting point for calculating the lighting load in a dwelling unit. Table 220.12 provides general lighting loads for various occupancies expressed in volt-amps per square foot. Table 310.15b16 provides allowable ampacities of insulated conductors rated up to and including 2000 volts. These tables are essential for selecting the correct wire size and overcurrent protection for a circuit. The National Electrical Code Handbook provides additional explanations and examples to help understand the code requirements. The handbook is a valuable resource for electricians and anyone involved in electrical work. The local authority having jurisdiction, or OJ, is responsible for enforcing the National Electrical Code and any local amendments. It is important to consult with the AHA to ensure that all electrical work is compliant with the applicable codes. The AHA may have additional requirements or interpretations of the code that need to be followed.